Right, good day and welcome. Now we're looking at grade 12 Euclidean geometry. Specifically, we'll be looking at ratio, areas, altitude, and the proportionality theorem. Right. So if we look at ratio and proportion, should know that if I write A is to B or A over B, then I'm reading ratio A to B. No? So a ratio 4 to 5 can be expressed as 4 over 5. So in reality, what you're going to be doing when you're doing these problems, you're going to be breaking up lines in proportion. So there, you can say R divides PQ in the ratio 2 is to 5, right? Or in proportion, I can say PR over RQ is proportional to 2 over 5. And same here at the bottom, I have A. D divides AC, ratio minus 4 is to 9. Or I can say AD over DC equal negative 4 over 9. Right? That's just basic examples from things we assume you've done in previous grades. Right? Now we take areas and altitudes of triangles. There in A, I have a parallel line. In between, I have the triangle A, B, C drawn. I have P, Q, R drawn. Right, and as you can see from A, top there to the bottom, I have H drawn, and from P down there I have H, and they both meet at 90 degrees to show that it's height. If you look at figure B here, I've got parallel line. In it I've got triangle ABC, then I have ABD. They both have the same height. So in both cases, the two triangles have equal heights or equal altitudes, called H. Right? Because the bases lie in one line, you see that base BC and that base QR, while the opposite vertices A and P there lie in parallel to the baseline. So parallel line simply means the space from here to there is the same as the space from there to there, space from there to there. That's the only way they can be parallel. So we should know in any triangle now, if I say area, it's half times space times altitude or height. So if I do area triangle ABC here, that equals half times my base, which is BC, times my perpendicular height, H. Area of PQR equal half times QR times H. So if I say area triangle ABC divided by area triangle PQR, that would equal half BC times H, half QR times H. Half and half would cancel, H and H cancel, so that gives me BC over QR. So, a basic rule, areas of triangles with equal altitudes, and the same ratio as are the lengths of their bases. So BC over QR. Right? Then that one, I can straight away say area triangle ABC must equal area triangle ABD, because they have a common base AB. AB belongs to both, and they have equal altitudes H for both of them. Right, and we're going to be using this to prove the theorem. Right, so let's look at the proportionality theorem. Right, so theorem 1a. If a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion, so you see there, that line there, parallel to a triangle, cuts in such a way that AD over DB equal AE over EC, right? That is called a proportionality theorem. Short line parallel one side of a triangle. Right, so given triangle ABC, D, as you can see, is on the line AB, E, as you can see, is on the line AC, and DE parallel to BC, required to prove AD over DB. AD over DB, same side, must equal AE over EC in proportion, right? So that's the theorem. So first in exam, we were required to draw H and K for the altitudes of triangle ADE, right? And then we're going to draw TC and BE, right? So you see there, TC there in red, BE there to form triangle BDE, and to form triangle CED. Right, so if I say area triangle ADE, top triangle, over area triangle PDE. Right, ADE, because BDE is on my left hand side here, that would be half DB times H. Therefore, triangle ADE, I'm going to use half AD times H. Right, so the height there is H for both of them. AD over DB is on the same side. And there, H and H cancel, half and half cancel. So I have AD over DB. And I say equal altitudes. If I do area triangle ADE again, but this time over CED, this here my base is CE, therefore for ADE I'm going to use the base AE. Right, so that gives me half AE times K, and at the bottom half EC times K. Again, half and half cancel, K and K cancel, and I have AE over EC. So objective is to get to the common ratio based on what I've shown you previously. If we have parallel lines, we have the same height, right? Equal height, common base, therefore we get the same ratio. But area triangle PDE equal area triangle CED, so you see PDE and CED, they have a common base and they have equal heights. Right? So if this equals that, and ADE and ADE is the same, you can say area triangle ADE over area triangle PDE equal area triangle ADE over area triangle CED, and that means now that AD over DB must equal AE over EC. So in short, when I have two parallel lines, the sides, or my corresponding side from A to B, AD over DB, must then equal AE over EC. Or AB, the longer side, over the shorter side, AD, must equal here the longer side, AC over EC. Right? So that in short, proportionality theorem asked in 90% of the exam papers. So technically compulsory exam question for grade 12s in South Africa. And we continue and you look at the converse of this theorem. So the converse of proportionality theorem, if a line cuts two sides of a triangle so as to divide them in the same ratio, then that line is parallel to the third side. So if this line cuts it in such a way that those two over each other is in proportion to those two over each other, then automatically we can conclude that DE must be parallel to PC. So given triangle ABC, D and E divide AB and AC in the same ratio, meaning AD over DB equal AE over EC, required to prove DE parallel to BC. Right, so for the proof, we're going to draw H and K for the altitudes, again H and K, and we're going to draw DC and PE. So again, I can go area triangle ADE over triangle PDE, so I want this as a base and that is my base. That give me half AD times H and half DB times H. Again, half and half cancel, H and H cancel, so I'm left with AD over DB. And there if I say area triangle ADE, so every time the same triangle on top, that would give me half AE times K, half EC times K. So half AE times K, half EC times K, half and half cancel, K and K cancel. I'm left with AE over EC. But they've given me that AD over DB equal AE over EC. Therefore, I can conclude that this area equals that area, right? And area triangle PDE then equal area triangle CDE. So if those areas are the same, then I can conclude that that line must be parallel to that for it to have a common base and equal heights. Right, so hope you follow, hope you understand. So as I said, this is just a theorem. In the next lesson, I'll be looking at how to use proportionality theorem to solve some basic problems before we go to more complex problems. If you enjoyed the lesson, please like, share, and subscribe.